We have a difficult looking radical on the board. We have the square root of 30 plus 2 square root of 99 plus 2 square root of 110 plus 2 square roots of 90. And we need to simplify this. So to begin with, what I want to do is I want to look at something. We'll start with, if we have the square root of a plus square root of b, and we square this, we end up with a plus b plus 2 square root of ab, just multiplying this expression out. And so we would like to get this to look something like what we have here in the radical. And this kind of works because we have a number and we have a radical starting with 2. We don't have 4 terms. And we want to do, and the reason I started with this is because we would like to have this be a perfect square. If we can find a perfect square for this, then we can just, like if this was a perfect square, then our answer would just be the square root of a plus b. So clearly this first expression won't work, but there's something pretty similar that will get us closer. We can look at the square root of a plus the square root of b plus c and square this. Now we can kind of do a little, turn this into a binomial like that, just putting parentheses there. And then so when we square this first term, we already know what that is because we just found it up here. And so that's going to be a plus b plus 2 times the square root of ab. We'll have a c squared, and then we're just going to multiply middle terms, and we'll have c squared of a plus c squared of b, but we'll get that twice multiplying it out, so we'll have another c squared a, c squared of b. So then I can summarize this. I'm just going to bring all the put all the numbers together and all the radicals together. And so what we'll have for this is a plus b plus c squared, which again is just going to be a number, plus 2c squared of a, 2c square root of b, plus 2 square root of ab. And then you'll notice what we have is we have something that really does match this. We have 4 terms. We have 3 of them are radicals. And you notice here that each of these have a 2 coefficient outside, so it kind of matches that pattern too, although we have this 2c here. So it's not quite an exact, I mean, this would be exact if the c is 1, but we have a pretty good match here for what we have in the radical. So then we just have to find some way to get it into this form of, and then because this is squared, when we have it inside the radical, we can then just, the answer is just going to be the inner part, square root of a plus square root of b plus c. So next we just need to find our values of a, b, and c, and we want to kind of match up what we have in this identity to what we have in the radical. I think the best place to start is with the 3 radicals. So we notice that this needs to be in the form where we have a radical a, or a, the square root of a, we have the square root of b, and then we have the square root of ab. So it would be nice if we could say like 99 is a, 110 is b, and 90 is ab, but you'll notice if you multiply 99 times 110, it's not equal to 90. And you could multiply this in any order you want, any way, but none of this is going to work. Like the smallest 2 numbers, 90 times 99 is not 110. So we just don't quite have it in the right form yet to have our AB and AB in the radicals. So we're going to need to do some simplification. You'll notice that the AB term has 2 of the coefficient, but these other 2 have this coefficient 2c. So what we could do is we could try to pull something out of some of these radicals. The first thing, what I want to do is I want to take each of these radicals and look at the prime factorization. So 99 is actually 9 times 11, or 3 squared times 11. 110 is going to be 11 times 10, or 11 times 5 times 2. And 90 is going to be 3 squared times 5 times 2. And what we'd like to have is we want to have some perfect squares that we can use. So I noticed that 3 squared and 3 squared. So we could pull that out of those 2 radicals, and we could rewrite our expression like 30 plus 2. Then for the 99, we can pull a 3 out. So we have 2 times 3 square root of 11. 110, there's no perfect square in there, so we'll just leave that. Plus 2 squared, 110. Plus, and then here in the 90, we'll pull out a 3. So we'll have 2 times 3 square root of 10. And then let's just simplify that. We're going to have the square root of 30 plus 6 square root of 11 plus, I'm going to actually move this one over, and we'll have 6 times the square root of 10 plus 2 square root of 110. And now notice if we said A is 11, B is 10, then 11 times 10 is 110. So this can be our AB. And so that part, and our radicals are actually making sense, where we're multiplying 2 of them to get the third one. We also have our 2 in front of the AB term, so that's good. The 2c just indicates, okay, each of these terms are even and they need to be the same, so that's fine. The only thing left to check is this 30. Is that 30 going to be a plus, we want the 30 to be a plus b plus c squared. So we're saying, let's see, a plus b plus c squared. We've chosen a to be 11, b to be 10, and then c is just this number that we pulled out, which is a 3, plus 3 squared. And so we add this up. 11 and 10 is 21, plus 9 is 30. So that makes sense as well. So we can actually rewrite this whole thing. Let's just do that. Going back to our formula, we know our a, b, and c. So we're going to have square root of a, which is 11, b, which is 10, and c, which is 3 squared. But because that's all in the square root, we're going to just have an answer. Our answer is just going to be this. So it's going to be square root of 11 plus square root of 10 plus 3. And that's it. Got this problem from a quiz I created recently on simplifying radical expressions of this form. So I'm just going to provide a link in the description for you if you'd like to try the quizzes. Feel free, and I hope you check it out.